In this section, we're going to talk about complementary angles. Complementary angles are angles that add to be 90 degrees. So in a right triangle, the other two angles in a right triangle add to be 90. So if we know theta, we can find the other angle just by subtracting it from 90. These are cofunction identities. And all it's saying is the sine is the same as the cosine of 90 minus theta. So if you subtract the angle from 90, then that's giving you another angle, which is complementary, and it makes it a cofunction with sine. And once we graph these, you'll see how that makes sense. It's opposite with cosine and sine. And then tangent of theta is cotangent of 90 minus theta. And cotangent, same type deal, but with tangent. And then secant of theta is cosecant of 90 minus theta. And any of these 90 degrees can be replaced with pi over 2 radians, by the way. So example 1 says, find a cofunction with the same value as the given expression. So we know by our cofunction identities that sine of 46 would be equal to the cosine of 90 minus 46. That is the cosine of 44 degrees. So what this tells us is that the sine of 46 degrees and the cosine of 44 degrees are the same thing. Then cotangent of pi over 12 is equal to the tangent of, this time we use pi over 2 instead of 90 degrees, minus pi over 12. And we'll need to get a common denominator. So let's use 12 because that'll work. 2 goes into 12 6 times, and we have 6 pi on top. Subtracting, we get tangent of 5 pi over 12. So the cotangent of pi over 12 will give you the same thing as the tangent of 5 pi over 12. For example 2, we're going to look at proving some identities. So it says cosecant squared of theta times tangent of theta times sine of theta times cosine of theta equals 1. Is this true or not? Do all those things multiplied equal 1? Well, let's start by using a reciprocal identity for cosecant. So that'd be 1 over sine squared of theta. And then tangent is sine over cosine. And then we've got sine and cosine still. And some of these things will cancel out. So one of these sines will cancel out with that one. This cosine will cancel out with that cosine. And the other sine here will cancel out with that one because realize these are on top of 1, right? So they'll cancel out with the bottoms. So in fact, this is equal to 1. So we can say that it is true. By the way, if I ever switch slides too fast for you, you can always pause it, of course, and stop and copy what you need or repeat my instructions if you need to. Here, we're trying to show that tangent of theta times cosine of theta is equal to 1 minus cosine of theta. So let's change tangent to sine over cosine. Our cosines will cancel out, and we're just left with sine. There's not a whole lot else we can do with sine. And sine is not equal to 1 minus cosine. So this one would be false. And example 3, it says find the exact value of each expression without using a calculator. Well, how are we going to do that? Let's see. We know that sine over cosine is tangent. We don't know what the tangent of 39 degrees is. But we know that tangent of 39 minus tangent of 39 better give us 0. Anything subtract itself will give us 0. So that's all for that one. For part B, we've got cosine squared of pi over 4 plus 1 over, let's change this cosecant to sine. So 1 over sine squared of pi over 4. We don't want a fraction in a fraction, so if we flip and multiply, then we actually get sine squared of pi over 4 here. Now I'm going to tell you that equals 1. How do I know that? Remember the Pythagorean identity that said sine squared plus cosine squared equals 1? Well, that is this case. We have sine squared and cosine squared, and they're of the same angle. That's important. And so this must be equal to 1.